So in problem 5 of the free response questions, we've got this table of values, and they give us that functions f and g are twice differentiable. And so what we want for part A is we want to find h prime of 7. Now h is f of g of x. So this means this is going to require chain rule. So h prime of x is equal to f prime of g of x times g prime of x. And then we have h prime of 7 equals f prime of g of 7 times g prime of 7. So let's see. G prime of 7 is going to equal 8. G of 7 equals 0. So now we need f prime of 0, so that's 3/2. And so 8 divided by 2 is 4, times 3 is 12. So there's our value for h prime of 7. Letter B. They give us that k is a differentiable function with this rule right here. K prime is equal to f of x squared times g. The question is the graph of k concave up or concave down at x equals 4. So if we're talking about concave up or concave down, this means we need the second derivative. So we need to find k double prime. Now here this is going to require chain rule because f of x is being squared, but we also are going to need product rule. So the derivative of this first part, that's going to be 2, it's the outside, leaving f inside, and then the derivative of the inside is f of x. Now it's still times g of x. Then we're going to leave that first one alone, times g prime of x. So now they're asking specifically at x equals 4. So now we're going to plug in 4 into this. So f4 times f prime of 4 times g of 4 plus f of 4 squared times g prime of 4. All right, so f of 4 is equal to 4. F prime of 4 is equal to 3. G of 4 is equal to -3. And let's see, f of 4 is equal to 4. So we have that value again. Times g prime of 4 is 2. All right, so almost there. All we just need are some computations. So 2 times 4 is 8, and then 3 times 3 is -9. 4 times 4 is 16, times 2 is 32. So we have -72 plus 32, so that gives us -40. So we can say that k is concave down at x equals 4 because k double prime of 4 is less than 0. So that was part B. Part C, here we've got this function m. It's defined this way. We want to find m of 2. So we're going to plug 2 everywhere we see an x. 2 cubed, 2 f prime t dt. So 2 to the third power is 8, times 5 is 40. Now by the fundamental theorem of calculus, the antiderivative f prime is f. So this is f of 2 minus f of 0. So f of 2 is 7, and f of 0 is 10. So you have 40 plus 7 minus 10. So that's, these two numbers make -3, so we get 37 for our value for m of 2. And then part D, is this function increasing, decreasing, or neither at x equals 2? Well, if a function is increasing or decreasing, we can tell that by finding the derivative. So the derivative of 5x cubed is going to be 15x squared. And the derivative of this integral, according to the second fundamental theorem of calculus, just leaves f prime of x. So now we care about x equals 2. So we're going to plug in 2. So we get 60 plus f prime of 2 is negative 8. So we get 52. So we can say m of x is increasing at x equals 2 because, let's clean that up, m prime of 2 is greater than 0. There's our justification. All right. Thanks for watching, everyone, and we will see you in the next problem.